Hello everyone, I am Udaya, working as Assistant Professor in the Department of Agricultural Engineering, Sri Shanmuga College of Engineering and Technology. In continuation to the previous video on Introduction to Remote Sensing, in this lecture video, we are going to discuss about the topic Electromagnetic Radiation. So, electromagnetic radiation or energy, so it is the energy propagated from sun. Okay, so it is in the form of interaction between electric and magnetic fields which are perpendicular to each other. Okay, all electromagnetic waves travels through the space at the speed of light, so that is 3 into 10 power 8 meter per second. Visible light, ultraviolet rays, infrared rays, radio waves, X-rays are different forms of electromagnetic energy. So electromagnetic waves are mainly characterized by frequency and wavelength. So let me tell what is wavelength. So wavelength is nothing but the distance between two successive wave crests. As you see in this image, so the distance between two successive wave crest is called wavelength, and its unit is meter, and it is represented by a symbol lambda. Okay, the next important factor is frequency. Frequency is nothing but the number of wave cycles passing through a fixed point in a unit time. Okay, so number of wave cycles passing through a fixed point in unit time. It is represented by nu, symbol nu, and its unit is hertz. Let us discuss about some of the important characteristics of electromagnetic radiation. So electromagnetic radiation, it is a carrier of electromagnetic energy which is transmitted by sun in the field through space or matter. So the transmission of EMR is derived from Maxwell's equations. EMR can take two forms, one as waveform, the other one is particle form. So now let us discuss about waveform. EMR as transverse waves with the electric field and magnetic field located at 90 degrees, that is at right angles to each other, perpendicular to each other. And so here we get an equation C is equal to nu lambda, and considering the characteristics of EMR as particle motion, EMR can be treated as photon or light quantum. Here we get the equation E is equal to h nu. So the E is nothing but the energy, H is Planck's constant, which is having a value of 6.626 into 10 power minus 34 meter square kilograms per second. Nu, it is the frequency. So in this image, we will be able to describe the electromagnetic spectrum and different regions of electromagnetic spectrum, starting from the smallest wavelength having gamma rays, X-rays and all having very small wavelength in micrometer. So as you can see in the image, gamma rays having a 10 power minus 6 wavelength range, very small. And X-ray, it's in the range of 10 power minus 4. Then coming to ultraviolet region, so it is having its name ultraviolet because it is located very near to the violet region of the visible spectrum. So we will be heard about VIBGR, violet, indigo, blue, green, yellow, orange, red, the color shades of rainbow. So these are the color spectrum in our visible light also, which is having a wavelength of 0.4 to 0.7 micrometer. Then after visible region, we will be having red, that is infrared. Infrared, it is named after red region of the visible spectrum, since it is located very near to red region of visible spectrum. So infrared further grouped into three classes: near infrared, mid infrared and thermal infrared. Then after infrared, we will be having microwave region, which is having the longest wavelength, and it is nowadays most suitable for remote sensing, because microwave region, the main advantage is that it can even penetrate through clouds. So we get most accurate version of remote sensing images. Then coming our radio waves, it is used for radio telecast or broadcasting. Electromagnetic spectrum ranges from shorter wavelengths, that is gamma rays and X-rays, to longer wavelengths, microwaves and broadcast radio waves. So sun produces continuous spectrum of energy from gamma to radio waves that continuously showers the earth. So as you can see in the image, there are so many organisms that exist on our earth which can be visible to our eyes or which may not be visible. There are so many virus, bacteria, amoeba, electrons and protons which are not visible to our normal human eyes, but with the help of microscopes we will be able to look at those features like atomic nuclei, atoms, molecules, protozoa, a needle point. So these are all okay. This table, it gives the detailed description about electromagnetic regions of the electromagnetic spectrum. So gamma rays and X-rays are having a very small wavelength, ultraviolet region. So some earth surface material, primarily rocks and minerals, emit visible ultraviolet radiation. Then coming to our visible spectrum, so this is the light which our eyes can detect, and this is the only portion of the spectrum that can be associated with the concept of color. And it's having 6 colors starting from violet to red. Then coming to infrared spectrum, having a wavelength from 0.7 micrometer to 100 micrometer. It is located after a red portion of the visible spectrum. Then microwave region. Microwave region is the longest wavelength and it is used for remote sensing. The main advantage of microwave region is that it can penetrate through clouds. Next, radio waves. It's used for commercial broadcast and metrology. Then we will discuss about the sources of EMR. The main source of EMR is black body. So a black body is a hypothetical ideal radiator that totally absorbs and re-emits all energy incident upon it. The best example for black body is sun. So the total energy emitted from the object increases with increase in temperature, and wavelength varies inversely with black body temperature. So they are inversely proportional to each other, temperature and wavelength. Next, coming to the black body radiation. So black body transforms the heat energy into radiant energy at maximum possible rate. So sun is the perfect emitter and the ideal black. There are some laws which better describes the characteristics of electromagnetic radiation and which we would have studied in our physics also. So first law is the Planck's law. Planck's law explains the photoelectric effect and it also describes the spectral existence of a black body. Next, coming to Stephen Boltzmann law. As per this law, all matter at a temperature above absolute 0 degrees Celsius emit the electromagnetic radiation continuously. So according to Stephen's Boltzmann law, the amount of energy radiated by an object is a function of surface temperature of the object. And next one is Wein's displacement law. So here the wavelength at which a black body radiates its maximum energy is inversely proportional to temperature. Okay, so that's all about the basics of electromagnetic radiation. So I hope this video would be useful for you in learning the basic concepts of electromagnetic radiation. Thank you for watching.